On the transmitter side, we begin by including the SPI and the RF24 libraries. Then we declare the input and output pins that will be used by the Arduino Nano. So pin 4 will be used to reset the clock, and A0 will toggle the clock. A1, A2, and A3 will control the other parts of the mechanical arm. So A1 will control the wrist, A3 will control the main arm, and A2 will control the base. A4 and A5 are optional, but I will be still leaving it there. You can opt not to use A4 and A5 because this one will only be a provision for mounting a camera. Also for pin 8, which centers the camera pan function. Pin 7 will control the lighting, and pin 5 will be to activate a buzzer. Pins A7 and A6 will be used to control the motors for the robot car. So now we define 12 variables in an array, and we set up the RF24 CE and CSN pins 9 and 10 on the Arduino Nano. Then we set a pipe address. On the setup, we begin serial communication at 9600 baud. Only if you are doing checking on the serial monitor, but you can also comment out this if you don't need it. Then we set radio to begin and open the writing pipe. We declare the pin modes for the joystick, the cam switch, the button pins, and the buzzer. In the loop section, we set the data variables in the array to read from the joystick. Data 0, data 9, data 10, and data 11 are for buttons, while data 1 to data 8 reads from the analog pins on the Arduino Nano. After that, we send the data over to the receiver. On the receiver side, we include the required libraries, the SPI and the RF24. We will also include the library for the PCA9685 and define the I2C address for that servo motor driver. Then we define the library to use I2C communication, which is from Andrew Davis of Brainy Bits. Then we define 12 packets to receive. Then we declare the RF24 CE and CSN pins 9 and 10 on the Arduino Nano. Then we have the same pipe address as the transmitter. Then we declare the variables to store the position of each servo, and 2 variables to drive the robot car. The other 2 optional variables, servo 6 and servo 7 for the camera. Then we declare the pins that will be used on the motor driver. For motor A, we have pin 5 for enable A, pin 4 for input 1, pin 3 for input 2. Note that the enable pins E and A and E and B, PWM pins must be used. So We declare motor speed values that start at 0. For the joystick, we declare values at 512, which is the start 0 position. Then we declare the pins to control the lighting. We declare a val equal to 0 initially for the push button pin, and we have a light on equals to 0 to declare the status of the lights, and we declare a variable push to check on the push button status. Then for the buzzer, we have the LED state, which is equals to 0 initially, and this will be the output of the LED, and we declare the variable for the buzzer. On the setup, we begin serial communication if you want to do some checking on the serial monitor. If not, you just cross this out. Then we begin the radio, open the reading pipe, and start listening. So initially, write the we make the LED pins low. Then we set the pin modes for the L298 motor driver as an output. We write to the pins initially in the forward direction. Then we initialize the servo mode for the PCA 9685. We wake it up from sleep. These are used for centering the servos initially. You can read in the comments why I crossed out some of these. Now we assign the outputs on the PCA 9685 module. So we select 0 for servo 0 position, pin 2 for servo 2 position, and so on and so forth. In the void loop, if radio is available, we read from the data received, and this controls the pin to reset the servo for the claw, and this sets the value for the claw. Controlling the servos using the PCA 9685. For data 1, if the value received is greater than 800, we increment the servo angle and assign pin 0 on the PCA 9685 module as an output. But if the data 1 is less than 300, we decrement that servo angle by 1 and output to pin 0 on the PCA 9685 module. So take note that we also set the limits. So while servo 0 position is less than 400, it will continue to increment the servo angle. And if data 1 is less than 300, it will decrement up until it's greater than 10. So this is to prevent the servos from overshooting. The same goes for data 2, data 3 until data 8. Basically, they're all the same. Data 5 and data 6 controls the motors, and depending on the values received, if it's less than 460, this moves the motors backwards, and if the value is greater than 564, this moves the motors forward. Else, if the value is in between 461 and 563, the motor will move. This part enables the motor enables to control the motors to move left and right. So this data 10, data 10 reads the push button value, which is for the latching button. I've also included to use millis instead of using a delay that would otherwise block the program. So the same goes for the buzzer. And for the buzzer, which is only a momentary switch, I've set as LED pin to turn on momentarily while the button is being pressed.